All right, now we're going to talk about cofunctional identities. And the first one is sine of pi over 2 minus u, which basically thinks about this here is if this is an angle, if you have 90 degrees and you minus the angle, it's equal to the cosine value. Think about it. It's like your alpha angle. We talked about that. If this was, I think it's easier for people to see with degrees. If that was 90 degrees and I minus 30, well, that means I would have 60 degrees. All right? Well, that means then that I would equal the cosine value of 30 degrees. The sine of 60 would equal the cosine of 30, because remember u is 30. Well, yeah, that makes sense. Because sine of 60 is square root of 3 over 2, and cosine of 30 is square root of 3 over 2. So that's all that it's saying on the cofunctional. So then conversely, if I have the cosine of pi over 2 minus u, it should equal the what? Sine of u. And the same thing is going to be true for tangent. Equals the cotangent, and the cotangent one minus the u. And like I said, I think it's easier to see with degrees than it is particularly with the radians. But like I said, you're just taking the angle and you're minusing it. Will give you the same answer as the other trig functions, why they're called cofunctional. And then if sine works for cosine, then secant will work for cosecant, and cosecant will work for secant. So those are the cofunctional identities. Basically, I like to call them the complementary identities because you're talking about complementary angles in a sense. Cofunctional, another word for that might be complementary identities. That might make it a little bit easier to understand.